We can also solve quadratic equations by taking the square root. So again, like I had said yesterday, I just want to point out that the roots and the solution of a quadratic are the same. So those two terms are interchangeable. We talked about solving by graphing yesterday. So essentially we would find the x-intercepts of the quadratic. If we're going to solve by square roots, we are going to isolate the squared term and then solve by taking the square root of both sides of the equation. And the details on that are here on this slide. So one thing that I do want to mention is that you can only use this method if the quadratic has only a squared term and a constant term. So there's no linear or x term. So for example, if we had something like, I don't know, 25x squared equals 4, we can solve that using square roots. There's no x. Whereas something like 25x squared plus 3x equals 4, this x term means that we can't solve by taking square roots. So in order to solve by taking square roots, you're going to isolate that squared term. So we're going to isolate that x squared. Then you take the square root of both sides of the equation. One thing to note here is that when you take the square root, you do get a positive and a negative. So we'll put that plus or minus as part of our solution. And then we simplify the remaining radical. So we're going to look at a few examples. Here's one, 4x squared minus 31 equals 49. So here we can solve by taking square roots because we only have an x squared term and a constant term. There's no x to the first power. So in order to solve here, we're going to isolate the x squared, just like it was an x if this was a linear equation. So we're going to start by adding 31 to both sides of the equation. So it'll be a 4x squared on the left and then an 80 on the right. We still want to isolate this x squared, so we're going to divide both sides by 4. So 80 divided by 4 is 20. And then we can take the square root of both sides of the equation. So the squared and square root are going to cancel, and that's going to leave us with x equals. On the right-hand side, the square root of 20, like I said, we always get a plus or minus because if we take a positive and square it, we get a positive. And if we take a negative and square it, we get a positive. So plus or minus square root of 20, and then we can go ahead and simplify this radical. We can use a factor tree. It's a square root, so we're looking for groups of size 2. 20 is 2 times 10. 10 is 2 times 5. So we can pull out a pair of 2's, leaving us with that leftover 5. So plus or minus 2 square roots of 5 would be our solution. Here's another example. We here can solve by square roots because we only have an x squared and nothing else. So we can go ahead and subtract 9 from both sides. We have 3x squared equals negative 9. And then we can divide both sides by 3. So x squared equals negative 3. We can take the square root. So we end up with x equals plus or minus the square root of negative 3. Now we can simplify this, and we're going to learn how to do that in the next section. But essentially, we can't take the square root of a negative number and get a real number solution. So because this is the square root of a negative, this would tell us that we have no real solutions. Again, in the next section, in section 3.2, we will learn how to deal with negative radicals. This one looks a little different from the rest. So you have this set of parentheses squared, and we can use square roots to solve this type of equation as well. If we can isolate any quantity squared, we can solve by taking square roots. So we're going to get this set of parentheses by itself. So we have to get rid of the 2/5. You can get rid of a fraction by multiplying by the reciprocal. So we're going to multiply both sides of this equation by 5/2. So on the left-hand side, 5/2 times 2/5, that's 1. So those are going to cancel. And you're just left with x plus 3 to the second power. This 5 is really 5 over 1. So I can multiply across the top to get 25. Oops. And across the bottom, that's not a 4, that's just a 2. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Now I can take the square root of both sides. So plus or minus the square root of 25 over 2. I'm going to split this up into two radicals. I'm going to split it into the square root of 25 over the square root of 2, because I can simplify this square root of 25. That's 5 over the square root of 2. I can't leave this square root of 2 in the denominator. I have to rationalize by multiplying by a form of 1. So I can get rid of the square root of 2 in the denominator if I multiply by square root of 2 over square root of 2, because now on the bottom this is the square root of 4, which is really just 2. Up top, that's plus or minus 5 square roots of 2. So the outside stays outside, the inside stays inside. So I have x plus 3 equals plus or minus 5 square roots of 2 over 2. I now need to subtract 3 from both sides. It's not, we'll call it a like term with this radical piece because of that square root. So I really have x equals negative 3 plus or minus 5 square roots of 2 over 2. So you have a few more book problems for homework tonight, and then we will continue into solving quadratics by factoring.